welcome everyone who has made it here. This is going to be our first live session. We're hoping to do these twice a week on Tuesdays and Thursdays. We're planning on recording them and posting them onto Canvas as well. So this is Math-266, Differential Equations. My name is Caleb, one of the instructors. Jasmine is the other instructor.
I'm over here.
So maybe let's just briefly talk about this syllabus here and then make sure everyone is on the same page about how this class is going to work. So as you can tell, this class is all online. So pretty much you should be able to hope. Our goal is that you can do this anytime within the week. There should be each week we'll have some things you need to do, and as long as you get that stuff done inside that week, you should be able to do this kind of whenever. And so that's the goal, is that there isn't anything that you're necessarily required to attend live, although we would appreciate you guys coming to these recitations. We think that would be very helpful for you guys.
Yeah, I highly recommend thinking of these recitations as similar to the calculus recitations when you went through that course, that we are here to help you understand the material, and it's not technically going to affect your grade or your success in the course much if you don't attend these, but I highly recommend coming and asking questions and working the problem sets that we bring to you, because they will give you a deeper understanding of the material.
Yeah, so this will be basically the one main time that you can ask questions live and get answers. But you can also, of course, ask questions on the forums, on Canvas, or by email to us as well. But
one student at least messaged me that the time of these recitations won't work for them on a regular basis. I was clear that it's their responsibility to make sure that they understand the material, and they're asking questions on the forum or sending us emails as needed. And we're planning to record these. This is recording right now. But in general, this is going to be a very valuable part of your class.
Great. So, let's see here. So that's about the recitations. We're going to be using this book, so you should all have access to this book electronically through WebAssign online. Here's kind of the course catalog description. Basically, this class is going to have three parts. We're going to study first-order equations, second-order equations, and then we're going to look at systems of equations. So there's a few things that we'll do throughout the course. All right. So you can see here on the syllabus, there's a list of things we're going to do. So you guys can kind of look over that if you'd like. Three main parts of this class are
accessible via Canvas as well, if you want to pull it up on your own, so you don't have to just read as quickly as possible while we're going through. That's fine too.
Yeah, so hopefully you've already kind of looked at this, so I don't want to just read it to you. So there's three main parts to your grade. The online homework through WebAssign is the biggest part. That's going to be the majority of your work. I mean, there'll be a few assignments every week, and I would expect that's going to take the majority of your time. So that's kind of where the main practice of the content of this course will be similar, exactly the same as if you had taken it during the fall or spring semester. Then we're also going to have some problem sets. You can think about these as written assignments. They're kind of like take-home tests. There are going to be three of those. And so basically we're going to give you a few problems. You'll have to handwrite your solutions over the course of a couple of days and then turn those in online to us to grade as well. So you can kind of think that's kind of our main way. You can
just use your phone to photograph your solutions or whatever, but the important thing is that you personally are writing down these solutions, working out these problems by hand.
So you can think about them as take-home tests, but you can also you can use whatever resources you have available, your book, online.
Exactly. Each other, work together,
work together.
Highly recommend working in groups.
And then the last part of your grade is going to be these kind of weekly or bi-weekly discussions. And so we want you guys to each basically submit a main reply by Wednesday, and then submit 2 comments or replies to other people's by the end of the week. And so this will be kind of a way to discuss different things. So like this first week was just introducing ourselves, but we'll have more mathematical type discussions related to differential equations as we go through the course as well.
Our hope is that the web assign, of course, will expect very explicit answers. The problem sets, we want you to really work through the process and show that you know the logic behind how you're working these problems. And the forum discussions, we want to encourage some open discussion about how you're approaching these and looking at some interesting examples of situations that we don't know how to work very well yet. And all sorts of things like that. We want to really be able to explore all the levels of how we work these problems.
Exactly. So then we kind of go into some details about the WebAssign and the forum discussions, and you can see there's a rubric here about how we will grade those discussions. And then we'll have these problem sets, so there'll be 3 of them, and then we give the weeks that we're going to assign those on week 3, 6, and 8. And then again, they should be consist of 6 problems. We're planning on posting them on Tuesday, and they'll be due by the end of the day, Friday. So that should give you 3 days at least to work on them. And then here's our rubric for those problems. Basically, the class policy is just be aware of those. I mean, if there's anybody causing problems, we'll deal with that accordingly. But I don't foresee any issues with that. And then here's kind of just a tentative schedule about the course. And so we probably may or may not change this as we go along, but this is kind of our plan at the start of the semester. So before we go any further, does anyone have any questions related to the format of this course or the syllabus? Chat. So yeah, in the chat here, somebody asked about problem sets. So this is graded homework. I mean, you can think about it as like a take-home test or just like a written homework assignment. It'll be 6 problems, and they'll be every couple of weeks. So they'll cover all the material you covered recently in the last couple of weeks. Okay, and they might also cover previous material as well. So basically, any material that you covered up to that point, we might ask a question about, and we're looking to see a full solution instead of just as WebAssign, you just give the final answer. We're looking to see a process a little bit and just a little bit more kind of way to gauge that how you're progressing in the course.
And your deeper understanding of why you're doing each of these things, and not just like you do step this, and that's the answer.
And get to the final answer.
Try to really talk about why you're doing these processes, what you're seeing in the question that's triggering you to think, oh, because it has this form, I know that I use this method, and things like that. But you can think of these similarly to a take-home exam.
Right.
We're spacing them approximately the way that exams would be. But they shouldn't be, they shouldn't be too high stress. That's the thing. Like, you are absolutely invited to work with each other, to Google for any kind of hints that you need. You can email us for, like, if you're really stuck on something, make sure you're communicating with us. Make sure you're posting it on the question forum and these things. We want you guys to be able to have every resource available to you.
So there won't be any exams beyond that. I think someone was going to ask. Yeah, so that's kind of the format. So we want you guys to be involved. I think that'll be the best. With these online courses, there's a tendency to just do the baseline and get by, and that might not. These summer courses are rather short. I mean, you only have 8 weeks to cover what used to be 16 weeks of material, so it's going to go fast. So just kind of stay active, stay involved, and make sure you're communicating with us, and we want to help you succeed.
Yeah, exactly. And if you find that you're starting to have trouble, make sure that you do reach out to us. We are completely understanding humans who have our own struggles in our own classes sometimes. We understand where you're coming from. So just make sure that you send us an email and let us know. If you can't get a homework assignment finished on time, like, we have the ability to do something about that and really help that situation. So let us know. That's what I'm saying.
All right. Any other questions?
Also, these recitations, just to go back, I think that the plan at the moment is that Caleb and I, so Caleb is going to take Tuesdays and I am going to take Thursdays. And what we want to do is take this as a time to go through some problem sets and really work through solutions, maybe discuss the material a little bit more in depth than necessarily the lectures have. And so if you guys have any questions, if you watch a lecture video and you find like you didn't really understand why they did that thing, make sure that you bring that question here because we can really discuss it as a group.
Yeah. So yeah, I think the question is just a little bit of more instant feedback, answering questions, doing similar examples to the lecture, but more in depth and maybe at a little slower pace so that everyone is understanding. Okay. All right, so I guess with that, let me just talk a little bit about this first couple sections, just course about this semester. So the interesting thing about this class is basically there's only one goal for this course, and that is to learn how to solve differential equations. And we're going to be learning over the course of the semester a whole bunch of different methods to solving a whole bunch of different types of differential equations. So the first question is, what is a differential equation? And it's basically what it sounds like. It's an equation that has a derivative in it of one or more things, functions we're trying to find. So for example, we're used to equations that maybe look something like this, that look like, y equals x squared plus 2. And, if we set y equal to 0, we can try and solve for x. And in that case, x we're just looking for is just a number. Okay, so that's not a differential equation. That's just a regular equation. A differential equation involves a derivative. So for example, the simplest one you might think about is like y prime equals y. And what does this say? We're looking for a function y whose derivative y prime equals itself. Okay, so this is, instead of just looking for a number, we're looking for a whole function y that satisfies this. So if we remember a little bit from our calculus, the only function whose derivative equals itself is y equals e to the x. Okay, so that's the solution to this differential equation here. Y equals e to the x. The whole function that satisfies this equation right here. Okay, and you can do a whole bunch of different things. So this is the simplest case. We could do more complicated ones. You have like y double prime plus maybe sine of y equals cosine of x. That's a pretty complicated one. You can also have different things. So you could have like partial derivatives. You could have like partial y, partial t, plus partial x, partial t equals 0. And in this case, both y and x are functions of t. Okay, and this would be called a partial differential equation. So that's kind of the next step. We have different types of differential equations. We have ordinary differential equations, which we call ODEs. And those are basically, we only have one function that is a function of one variable. Okay, so in this case, y is a function of x, and we're only doing ordinary derivatives of the function y. And this is the type of differential equation we're going to be focused on to this course. Okay. So, y prime equals y is another example of this. dy dx equals y squared is an example, things like that, where we only have one independent variable and one dependent variable. Okay, the other type that we won't really cover, but you should be aware of, is called partial differential equations. And this is the type of equation where we have a function y, but it has multiple different independent variables. So in this case, we have the variables t and x. So y depends on both t and x, and we can take partial derivatives of that. So if you've done multivariable calculus, you'll be aware of what partial derivatives is. Otherwise, just know it's a derivative with respect to only one of multiple variables. Okay. So this is one. This is called the advection equation. Another really common one is the wave equation. That looks like this: partial y second derivative equals partial y second derivative with respect to x. Okay, so that's the wave equation. So these are partial derivatives, and they're even more complicated because instead of having to solve just y is not just a function of x, it's a function of x and t. So it's something like, so it's a little bit more complicated. Okay, we won't be talking about this much, but in physics and engineering, this is a really common type of equation. But first, we need to understand ordinary differential equations before we can get to this. So that's the point of this course here, is to talk about ordinary differential equations. All right. So just maybe briefly, let's mention some notation things. So Leibniz notation is when we talk about this d notation, dy dx. Okay. Prime notation, we have the primes. You should be aware of that. These two things are the same. Newton dot notation looks like this. This is, again, one derivative. This is equivalent to dy dt. So the dot generally means time derivative. Okay, so you might see this in physics and engineering sometimes. We won't really use it in this course, okay, but it represents differentiation with respect to time. And then when we're doing partial derivatives, you might see this subscript notation. So you may see, well, y sub t. That looks like, that's like partial y, partial t. Or if you have like two t's, that would be the second derivative of y with respect to t. Okay, and so that's something you should also kind of be aware of. There's the subscripts mean derivative. Okay, but again, we won't be really talking about this type of equation in this course. All right. The order of an equation. The order of the equation is just the magnitude of the highest derivative. Okay. So it's basically, in this first equation here, we have a first derivative of y, and we don't have any other derivatives. So the order of this first example is just 1. Okay. Similarly, this second example has a second derivative. Okay, so the order of this equation is 2. Right. So one thing we need to be careful of in our notation thing, in this third example, we have a second derivative, and then this notation right here means the first derivative to the 4th power. Okay, so in this case, the highest derivative is still 2. This is only a first derivative, and so the order of this equation, again, is also 2. And then in terms of partial differential equations, it's still, again, only the highest derivative. And so it would be, in this case, it would be 2 again. All right, so just the order just means the highest derivative. And the higher you go up, generally the more complicated the equation gets a little bit. Okay, so at first, we're just going to focus on solving first order equations with only have one derivative in it, first derivative in it. All right. So when you look at an equation, differential equation, you want to figure out what order is it. So you want to look at what is the highest derivative, and then you want to think about, is it linear or nonlinear? Okay, so what does it mean to be linear or nonlinear? A linear equation basically is going to have to be look in this form here. And what we mean by linear is whatever our dependent variable is, we're only multiplying by the independent variable, or we're adding things, or we're differentiating. Okay, so if you can see here, all these derivatives of y, we're just multiplying by x and adding them to other things. Okay, we're not doing anything to the y except taking a derivative adding, or multiplying with x. All right, so, and anything that doesn't look like this is going to be nonlinear. So for example, nonlinear things would have things like y squared, or like sine of y, or e to the y, or things like that. Okay. So looking at these examples here, we see that we have dy dx plus x squared y equals e to the x. So this is the linear equation. Okay, we have dy dx. This y is only multiplied by x, and this e to the x doesn't have any y in it. Okay, so all the terms of y are linear. So this is linear. The second equation, we have a derivative of y, sine of x, that's still fine, but then we have a cosine of y. Okay? Cosine is nonlinear and it's acting on a y, so that makes this whole equation nonlinear. Okay. Now with this third example, we see we have y times e to the x, that's fine. We're just multiplying by x times y. That's still part linear. But this part here, derivative of y with respect to x, we're squaring it. Squaring is a nonlinear operation on a y. So that's going to make this nonlinear. Okay. And then this last example here, let's see, we have a second derivative, y, plus tangent x squared times the first derivative of y. All right, so far that's all right. So we're just taking this tangent x squared. If we're thinking in terms of x, this is nonlinear. But since we're only care about the dependent variable y, that's okay. We're just multiplying by something of x times dy dx equals negative 5y. And again, this is just a number times y. So that should be, this is a linear equation. Sorry, my phone is dying. Let me just grab a way to charge it. All right, so I guess for now, does anyone have any questions about what we've talked about, linear or nonlinear in order of differential equations? Makes sense, Siri? That should kind of be this. The first assignment will just be asking you questions about things like that. All right. All right. So in general, nonlinear is really, really hard. Okay, so we're going to be mostly focused on linear equations in this course. Once you get to nonlinear equations, it's, in a lot of cases, it's basically impossible to solve. Okay, so we're going to be mostly focused on linear versus equations, but you should be able to identify which one is which. Okay, so a slight change from a linear equation to a nonlinear can make the problem drastically harder. Okay, all right. So the other main thing that we need to know in this class is basically how to check if we got the right answer or not. And that's one of the great things about this class is it's really easy to check your solutions. Okay. So if we have we're given a differential equation and a solution, it's really easy to check. We just basically plug it into the equation and see as we simplify if the equation is true or not. Okay. So and for example, in this problem here, I'm giving an equation dy dx equals 3y. And I tell you the solution should be y equals e to the 3x. Okay. I don't know if that's true or not at first, but I can check it by taking the derivative. So if I find dy dx of our solution, I take the derivative. Use the chain rule, that would be e3 e to the 3x. I can plug that into our equation. Dy dx is 3 e to the 3x. And then 3 times y, 3 e to the 3x. And I see that both sides are the same. Okay, so that checks. That means this is a solution to our differential equation. And so we should be able to, after you work through a problem and find a solution, it's always maybe a good chance to go back and plug it into the equation and see, is that true or not? Okay, so we should always be able to do that. The other thing you should keep in the back of your mind is, where is the solution valid? Okay, so in this case, this solution is valid everywhere. So the interval that is negative infinity to infinity. But sometimes our solution y maybe is discontinuous somewhere, or doesn't have a derivative somewhere, in which case it might only satisfy the differential equation on a certain smaller interval. And so you need to keep in mind, where is that solution valid or not? Okay. So in general, a solution has both the function and the interval that we're concerned about. Okay, so be thinking about that a little bit. All right. So let's just practice another one of these. So I have a differential equation here, x y prime plus y equals 0. And I tell you that the solution is y equals 1 over x. Okay, so in order to check this, I find my derivatives. So y prime of 1 over x, what would that be? So this is like x to the minus 1 power. If I use a power rule, the derivative becomes minus x to the minus 2. And then I'm just going to plug that in everywhere. We have x times y prime, which I just found is negative x to the negative 2, plus y, which is x to the minus 1. Does that equal 0 or not? Okay, and you multiply through. This is negative. The exponent rule, we would add these exponents. So 1 plus negative 2 is x to the minus 1 plus x to the minus 1. Okay, and we see those things cancel out. We get 0 equals 0. And that checks that is a solution to this differential equation. Okay. So one thing that you want to think about, what is the interval of this? 1 over x, if I were to graph this, looks something like this. And so we see here at 0, 1 over x is discontinuous. And so this interval actually is basically anything that doesn't have 0 in it. Okay, so for example, an interval maybe would be like 0 to infinity. And you could include negative infinity to 0, as long as you don't include 0 itself. So this solution satisfies this differential equation everywhere except at 0. Maybe there's a different solution that does satisfy it at 0. I don't know for sure. Okay, but we verified that is a solution on any interval that doesn't include 0. All right. And that's kind of a good point, is that there are possibly more than one solution to these problems. So we'll find more out about that later. All right. Maybe one more example, a little bit harder. So this is a second order equation. It's linear, okay, because we're only differentiating and then multiplying by numbers or values of x and adding and subtracting. Okay. But it's second order because we have a second derivative here. So that means when I'm checking the solution, my solution y, I need to find both y prime and y double prime. So how do I do that? Y prime, I have to use product rule. So the derivative of x is 1 times e to the x plus x times the derivative of e to the x is just e to the x. All right, and then we could do the same thing here again. We got derivative of e to the x is e to the x plus x e to the x. We just did that, so that's e to the x plus x e to the x. If you add that together, you get 2 plus x e to the x. All right, and we plug that into our equation. So we have y double prime is 2 plus x e to the x minus 2. This is also, we can write this as 1 plus x e to the x. So 1 plus x e to the x plus y is plus x e to the x equals 0. All right, and then we can basically get all these coefficients here together. We have 2 plus x minus 2 minus 2x plus another x here times e to the x. Does that equal 0? All right, and we kind of work this out. We have a 2 and we have a minus 2. That cancels. We have plus x minus 2x. That all cancels. And we're left with 0 equals 0. So that is, in fact, a solution to this equation. All right. So again, this is not too hard of a process. And so it's something you should become familiar with as we're kind of able to check our answers that we find later on in the class. One thing that I want to mention is generally we're interested in non-trivial solutions. And what I mean by a trivial solution is y equals 0. So in a lot of these examples that I've shown, if we plug in 0 for y, everything kind of goes away. Okay, so for example, on this one, if y is 0, then the derivatives are all 0, and it becomes 0 equals 0. And so that's true in a lot of equations. And so we kind of know that solution ahead of time generally, but we're trying to find other solutions besides that. This is kind of the goal of this course, because that's not really interesting. Y equals 0 means nothing's happening. All right. What time are we at? All right. So the other thing, the solutions I've shown you are all explicit solutions. And what I mean by explicit is that I have y equals to something. Okay, y equals to something. Sometimes when we're solving differential equations, we'll get to a point where we can't solve for y, at least not very easily. And in that case, we'll leave it as an implicit solution. So for example, in this case, we have this equation here. It describes a curve, but it describes it in an implicit way. We haven't solved for y. Okay. But we want to know, is this curve, is this function a solution to this differential equation right here? And the way we can check that is we have to remember back from Calc 1, Calc 2, implicit differentiation. Okay. What I mean by implicit differentiation is we're going to treat y as a function of x, and x as just as the independent variable. And so when we do the derivative of both sides here, I do the derivative of x squared with respect to x is 2x. The derivative of y squared, we think about y as a function of x, so we're going to do the power rule 2y, but then we have to do chain rule and multiply by dy dx. Okay, equals the derivative of 25 is 0. And so then if we solve now for dy dx, you subtract 2x across and then divide by the 2y, we get negative x over y. That matches our equation here before, so it is a solution, an implicit solution to our differential equation. Okay. All right, so those are the kind of two types of solution. We want to find explicit solutions as much as possible, but sometimes it's not possible to do that, and so we'll deal with implicit solutions instead, and sometimes that's okay. All right. So hopefully one thing you've kind of noticed is that potentially there's multiple different solutions, and in general, they'll only differ by a constant. Okay, so for example, if we think about this equation here, the example from before, if I had multiplied that solution by any constant, I would have gotten another solution. All right, so if I kind of do the same thing, y prime here is just 3c e to the 3x. I see we have 3c e to the 3x equals 3 times c e to the 3x. Okay, and that satisfies this equation. And so in fact, we have not just one solution, we have a whole family of solutions that for any c here, this is a solution to this equation. Okay, and that will in general be true. whatever the order of the equation, this is a first order equation, that's how many different constants there'll be in the general solution. So this family of solutions we call the general solution because it is true for any constant C. And sometimes we might also call it a one parameter family of solutions because we only have one constant. So that number of parameters, that number of constants should match to the order of the equation. So if we had a second order equation, we would have two parameters. We'd have two different constants that we could change. And whatever constants you pick, that would generate a new solution. All right. So in general, if you have an nth order differential equation, you're going to have n constants, n parameters. All right. And then kind of terminology, if we pick that constant, so say I picked 1 for C, we call that a particular solution. Okay, so we have general solutions where we don't set the constants, and then we have particular solutions where we do set the constant. So once you pick constants, it becomes a particular solution. And so we use that term particular solution and general solution throughout the course, So we might ask you find the general solution, or we might say find the particular solution, and that means you can pick a constant for the particular solution case. All right, and then the last thing kind of in this first section that you should be aware of is that sometimes we can have systems of differential equations. So in this case, we have two functions, x and y, and their derivatives depend on each other. So this derivative of y depends on x, and the derivative of x depends on y, as well as itself. And so this is a system of differential equations. And so in order to find y, we have to also find x at the same time. Okay, and this will be kind of the end of the course. We'll come back to how do we solve this type of differential equation where we have multiple equations. Okay, but you should keep that in your back of your mind that sometimes we might have differential equations that are linked with other differential equations. All right, so that's section 1.1, kind of just introducing what is the order, what is the type, and what if it's linear or nonlinear differential equations. Okay. All right, and then section 1.2, just kind of talk about briefly. We're talking about initial value problems. So what do we need by initial value problems? So we have differential equations, and if we have a differential equation, like I said before, we can find the general solution. Sometimes we'll in the next on Thursday, we will talk about how do you find this general solution right here. Okay, so we can find that. Initial value problems goes one further. It tells how do you determine what is the right constant to pick? And that's when we have initial conditions. So for example, you might give you a differential equation, and we'll give the part of the problem will also be initial conditions. So say we're trying to find y that satisfies this equation, and it starts at this value right here. Okay, once you kind of know that, once you know where does it start, that tells you what the constant should be in the solution. Okay, so if you're solving an initial value problem, there are kind of two steps. First, you solve the differential equation, find the general solution, and then once you find the general solution, then you can use the initial conditions to find the particular solution that satisfies those initial conditions. So in this case, I've given you the solution right here. So we could plug that in and check that it is a solution. Okay, I won't do that right now. You can do that on your own if you'd like. But how do I find should this constant be given this initial condition here? So what does that mean? It means I'm going to plug in these values for x and y and then solve for the constant here, c. Okay, so I know that when x is 0, y is negative a third. So I plug in negative a third for y, and then I plug in 0 for x. Okay, so e to the 0 is just 1, so this becomes 1 over 1 plus c1. All right, and we need to solve this equation right here. How do we solve this? Well, we can cross multiply. It's how we solve fractions like this. So we have 1 plus c1 times 1 equals negative 3 times 1, negative 3. Subtract the 1 across, so c1 is going to be negative 4. Okay, and so the particular solution will be 1 over 1 minus 4 e to the minus 6. Okay, so this is the particular solution to this differential equation that satisfies these initial conditions. Okay, and so generally finding the constants is not too hard. It's just solving an equation. Okay, it's going to come down to some algebra. Okay, and if in this case we only had one constant, so it's only going to be a system of one equation. If we had two constants, like this next example here, so I've given this differential equation, x double prime plus x equals 0, and I know the general solution looks like this, c1 cosine plus c2 sine, and I'm given two initial conditions here. Okay, so that's also the other key, is the order of the equation will be the same as the number of initial conditions. So this is a second order equation, two derivatives, means I need two initial conditions. I need the value of x and the value of its derivative. All right. So basically, I'm just going to solve these two equations with this function here, x. So what does that mean? So it means when t is 0, x equals 1. So we have 1 equals c1 cosine 0 plus c2 sine 0. Okay, so that's one equation. And then I also have this other equation here that has to do with the derivative. So first, let's find the derivative. X prime, take the derivative of this. It's going to be minus c1 sine t plus c2 cosine t. And then I plug in 0 for t, get minus c1 sine 0 plus c2 cosine 0. And that's going to equal this x value negative 1 here. Okay, so we have these two equations right here and right here to solve for c1 and c2. Okay, we have two unknowns, we need two equations. Okay, and so we know this one's not too bad. We know cosine of 0 is 1, sine of 0 is 0. Okay, so this tells us that c1 is 1. And this one it basically tells us the opposite. Sine of 0 is 0, cosine of 0 is 1, so this tells us c2 is negative 1. Okay, and so our full solution, our particular solution, x, then is cosine of t minus sine of t. Right, so that's the particular solution to this differential equation that satisfies these two initial conditions. All right, so that's kind of the main idea of 1 by 2 is you just need to know about initial value problems, basically just a differential equation plus initial conditions. Okay, and once you found the solution, you can find those constants by solving a system of equations related to the initial conditions. Okay. All right. Sorry, that was a lot of talking, but does anyone have any questions about those sections, that material? Everyone here okay? See all right? All right, well, I guess that's all for today. So on Thursday, we'll do this again. We're going to be talking about section 2.2, which will be our first, actually how to solve equations as separable differential equations. So before that class, you should kind of watch the video lecture on that and bring any questions you have, and we can, I guess you and Jasmine can talk about it on Thursday.
Yeah, how many of you have watched any of the lecture videos so far? Just like untop, unmute. Yeah, I did remute. Okay, yeah, awesome. Okay, I would like to challenge you to keep on top of those to make sure that you're watching. It won't always be just 2 videos to like sort before Tuesday and sort before Thursday. But try to make sure that you're watching those videos before recitations, right? So that you have some idea of the material that we're talking about before we're really discussing it, so that if you have any questions, we're able to really approach them here.
Yeah. So yeah, I think ideally, hopefully you kind of watch those, or you tried the homework and bring any questions this time, and we can you can answer those questions. And if nobody has questions, we'll have a few examples and things to show everyone. All right. Sounds good.
I think if there's nothing else, then we
I think that sounds good.
for today. Yeah.
All right.
Yeah.
This will be posted. So everyone have a good day, and I'll see you again.
If you haven't posted on the discussion forum, you should do that, by the way, because that'll be due Wednesday.